Hey guys, it's Ron. So this is the culmination basically of our three-part lab or scenario that we did on accessing an email server basically on a remote network. So what we had was our headquarters network or our headquarters was expanding. So now we have these remote sites that we have to basically provide access to. And so in the first part of the lab, what we did was we added some static NAT assignments on our headquarters router that enabled those remote sites to access an email server inside of it. Okay, and that worked just fine. And for some scenarios, that will be more than enough. The problem is it opens up our headquarters network basically to the outside world, which we don't necessarily want. We just want those remote sites to be able to access it. Okay, so the next step we did is we got rid of the NAT, the static NAT assignments on our headquarters, and we went ahead and implemented GRE tunnels from our remote sites back to the headquarters. Okay, and that was great too. Now from a remote site, it feels like the headquarters network is local to us, meaning that we can use those private IPs on the headquarters side without having to do any kind of crazy NAT configuration. The only problem with that was, again, the traffic that we're sending from a remote site to a headquarters is unencrypted. You know, if it were to be sniffed from the ISP side of the house, all of that traffic would be open. Any email that we sent from a remote site to a remote site or from a remote site to the headquarters, it all goes back to that headquarters and it all goes unencrypted. Okay, so in this part of the lab, what we're going to do is we're going to take those tunnels and we're going to apply IPSEC to them. Okay, so I've switched up programs here. I'm now using GNS3. It's another emulator program. It enables me to do some things that I couldn't do on Packet Tracer. On Packet Tracer, it's a great tool, but again, it's limited to what functionality they build into it. In GNS3, you're actually using the Cisco iOSs. Okay, so I will have the same functionality here as I would if I was sitting on a real router. Okay, so basically I've configured up the headquarters router, I've configured up the ISP, and now we'll configure remote 1. I've already built the tunnels, I've already added EIGRP, I've already configured the crypto stuff on the headquarters router, so we'll go ahead and configure that on remote 1. So if everything works out right, what I should end up seeing is as soon as IPSEC gets applied, I should see an EIGRP relationship build. Okay, so I'm on my remote 1 router. We'll go to global config, and the first thing I'm going to do is when you do IPSEC, you're doing it in two parts. So there's an ISACamp and an IPSEC. So ISACamp is what's going to initially kind of establish that secure link back to whatever host you're trying to build with, your peer, and then IPSEC will be applied. So we'll do a crypto. We'll do a crypto key, or correction, ISACamp key. And then we'll go ahead and specify the unencrypted clear text password. So we'll make it easy on ourselves and we'll just call it secret key. That'll be our key. We're going to apply it to address, and this is our peer address. So 172.16.0.2 is the address of the fast ether interface back on our headquarters router. Peer IP subnet mask. So I'm just going to do 255.255.255.255 so that it applies only to that specific IP. Okay, now let's see here. Crypto, we'll do IPSEC. Let's go ahead and build a transform set. We'll give it a name. Alright, and here's the kind of transform sets that we're going to apply to it. So we're going to be using AES encryption with an MD5 hash. Alright. and you have to specify both of them here. So MD5, hit my tab key. Alright, so now we've specified a transform set. Let's see here. Let's look at ISACamp again. I think I have to specify ISACamp profile. No, it's not profile. Let's do a policy. Policy 1. So basically you can specify multiple policies, and when it tries to build this ISACamp security association with your peer, it's going to go down through the policies and try the different policies until it finds one that matches and it can build. In my case, I'm only going to specify policy 1. And here we're gonna give it a couple of the details on what needs to happen in building that security association. So we're going to do authentication pre-share because we're using a pre-shared key, which we created. We'll do encryption AES. Now there's a couple different things you can use there. We're going to use the advanced encryption standard. We have a group. So Diffie-Hellman is the way that we exchange keys, so I'm just going to use Diffie-Hellman 2. Hash, we're going to use MD5. Now you can specify a lifetime here. I always max it out. And if you have any questions about these, I hate to say it because I mean people throw it out all the time, but Google is your friend, okay? A lot of these things can all be looked up in Google, and I found some great documentation out there and even do my own labs here. So we've specified authentication, we've specified encryption, the group, the hash, and now the lifetime. Okay, so now that we've created an ISACamp policy, let's go ahead and create a IPSEC policy. So we'll do a crypto IPSEC, or its profile, sorry. It's going to ask us for a name. We'll just call it IPSEC profile. Alright, and so in here we're going to just map in a couple little things that we've created along the way. So we're going to set now the transform set that we created. We're going to do a PFS. We'll do group 2 again for Diffie-Hellman. And let me see here, what else? That might be the only thing we have to specify in here. I'm going to do security association lifetime. I'm also going to max out the time here as well. So 86, 400. Alright. And now we're going to go ahead and apply it to the tunnel. So interface T0. Alright, so we'll do a tunnel. And now we can do protection. So protection, question mark, IPSEC, profile. And we're going to map it to that IPSEC profile. And we're just going to hit enter right there. And if I've done everything right, what you'll see is ISACamp goes on, and then we build an EIGRP relationship. Okay, so that's essentially it. Now the tunnel from our remote site to our headquarters router is encrypted. So anything that we send from network to network is going to be protected. Okay. Now there are a couple other ways, like I said, that you can apply IPSEC, and some of that has to do with, let's exit out here. I think it's crypto map, and then you're going to give it a map name. So a lot of people give it name CMAP, and you're going to specify ISACamp, ISACamp. I'm thinking it's profile. It's been a little while since I've did it in this method, and I don't know, I might have to look this one up again. But basically, once you create this one, you're going to do the same thing as we did with the IPSEC profile. You're going to have to link it into your transform set. You're going to have to link it in to which keys. Well, let me take it back. I'm not sure if you have to do that or not. Let's try it. So CMAP, ISA, KMP, profile, maybe. I don't think so. Let's try ISA, KMP. Nope, it's not that one either. Let me try. Thinking maybe it's the number here. It's been a while since I used this method. Yeah, there it is. IPSEC, ISA camp. We're just going to hit enter. Alright, it says it's not going to be applied until a valid access list has been configured, which we haven't done. But if you look in here, we have our same things as set. So if we did a set, we apply the transform set. We're going to apply, I think, our PFS. We might even specify an ISA camp profile. And then lastly, you end up doing a match. Okay, so you do match, address, and here's where you specify the name of the access list. So let's say I only wanted to apply IPSEC to a specific host out there when we talk, or a specific router when we talk. I would build an access list that basically grabs up just those IPs, so that when I apply it, I'm going to apply that access list here. So only IPSEC will only be triggered for that specific traffic to that network, basically. So then you would end up doing an interface FA00 crypto map, and you specify the name of the one you made. So CMAP. Okay, and I think, yeah, that would be it. So as long as your access list is correct, whenever traffic hits that interface that matches that access list, it triggers IPSEC to encrypt that traffic. Okay, so we didn't do that route. We just applied IPSEC to our tunnel. So what you'll see now, if we do a show crypto ISA camp SA security association, what we see is to our destination source we're active. Okay, so we built a security association between those two, and now we do a show crypto session, if I could spell crypto right. I'm showing that on port 500, which is typically the port that's used for IPSEC, I am up and active. Okay, so those are good indications that we're up and running. That one, we've built a security association and we're showing up and active on our tunnel interface. Okay, so that's it, man. That's kind of what I wanted you to get out of this series of labs, that you can take a problem, you can break it down, and there are multiple ways that you can kind of attack it. So first we attacked it with NAT. That was great, it worked, but it also made some other issues. Then we attacked it with our GRE tunnels. That was a great step in the right direction, but didn't quite get us where we needed to be. And now we've attacked it with IPSEC. So we've applied IPSEC to that tunnel. So now I feel confident that between my remote networks and my headquarters network, the traffic that I send between them is in fact encrypted and protected. So I hope you got something out of this lab series. Let me know what you think. Leave some comments. If you got extra questions, send them to me, and I'll try my best to answer them. And thanks for watching.